carried out research on various aspects of geology of India, and it's particularly known for his discovery of recent volcanism on the moon. He also established a state-of-the-art laboratory for carrying out reflectance spectroscopy of planetary materials and analogues under stimulated conditions. He is the recipient of inaugural COSP COSP AR Outstanding Paper Award for Young Scientist Scientific Commission B in 2008 and LPI Career Development Award USA in 2013. A heartfelt welcome to you, sir, for today's reactor session. And I also welcome Srinath, sir, Supriya ma'am, and all the participants for today's talk. Thank you.
Over
Over
to
to
Neeraj sir.
Thank you,
Thank you,
Afrin. Thank
Afrin.
you. Thank you,
Shall I
Afrin.
say?
Thank you. Yeah. Please. You would like to say something?
No, sir. You can carry
Okay,
on,
so I
sir.
can carry
Already
on.
we got
Okay,
late.
fine. It's
Okay.
already late.
Yes,
So
sir.
thank you, Afrin, for a wonderful introduction. And today we will learn a bit of about our nearest celestial neighbor, Moon. So before talking about the advances, I would like to tell you what do we know about Moon. Okay, unless I tell you that, you will not be able to appreciate how we have advanced. Okay, in this slide you see moon, and then you have lots of satellites. So the central one is the Chandrayaan-1 satellite. Then you have Kagwa and LRO missions of NASA, other space agencies. So these are some of the missions which have actually changed our perception about moon, geology of the moon. Okay, so you will come to know about that in just about half an hour from now. So that journey which I am going to take you. So now let me just tell you, just, can you go to the second slide, please? Yes. So since students are here, they would be very happy to know one thing, and amazed also, that moon has been scientifically studied for centuries. When I say scientifically studied, it is scientific study. It is not just visualizing the moon in the night sky, okay, from your eyes. If you can see, Galileo Galilei, for the first time, he has drawn this type of figures, and from these observations using his telescope, he could find out that moon has surface which is rough, uneven surface, just like on Earth. There are depressions and there are mountains on the moon. How he did? It was because of using this shadow. You see here, just at this is the limb of the moon, and you see there is a shadow. So from this shadow, I think I don't have any means to explain, but okay, fine. From the shadow, you can make out that there could be a obstacle, and that obstacle tells you that there is an elevated area in the region. And before, prior to this, moon was considered to be uniformly it's a sphere without any ups and downs. So that was for several years. It was considered like that. So telescopic observations continued. Next slide, please. Next slide, please. Yeah. So here you have the first atlas of the moon. You can just see such detailed observations were made by people like Johannes Hevelius. They were all astronomers, and they could make geological atlas of the moon for the first time. And such studies continued. However, next slide, please. Yes. However, the dawn of lunar exploration started only in the 1959, when Soviet space program wanted to explore moon, and they have sent approximate about 44 missions to the moon, and out of them 15 were successful. Just see the success ratios which in such type of missions people get. So uh, out of this, in 1959, first hit, there was an object which was just which hit the moon in, in the central part. Okay, and this is in the September of 1959. And first soft landing occurred in 1966 in the western edge of the moon in the Oceanus Procellarum. And if you see NASA's attempts, then NASA has, before they went for this famous Apollo program, they have sent lots of lunar orbiters and surveyor missions to the moon. And the surveyor missions have successfully soft landed on the moon at several places, and the success ratio was again 5 out of 7. So you can see the type of challenges which are involved in such type of missions. And then sample return missions. There were Apollo 11 to 17. This type of missions, they have gone, these missions, they were having rovers also, and they have tried to find out, they have brought samples to the Earth. 380 kgs of samples have been brought to Earth from these missions. This slide just disappeared, man. Can I attempt to share my screen from my system? If you can enable my screen sharing. Okay, so it has come again. So from this slide, I just wanted to tell all these kids, I see many kids in this, that in one line you should understand that any space exploration mission, okay, it is very challenging for any space agency, including our own. So we should always be hopeful for any mission we undertake, but fingers should be crossed, and we should always celebrate at the end of the success. So this is the message from this particular slide. Now there is a lot of problem. I do not know how to continue. Okay, but I will just say that most of our knowledge about geology of the moon came from these samples which were brought during Apollo time and the orbiter missions. The orbiter means the missions which were circling the moon, okay, in some orbit. So that was one mission which is Clementine of NASA, which was sent in 1994, and Lunar Prospector in 1998. And okay, so what do we understand from these two missions? This is the near side of the moon, this is the far side of the moon. I hope nobody has seen the far side of the moon because it is tidally locked. Okay, it is tidally locked. Only the near side of the moon is seen from the Earth. And if you see the near side, what do you see? There are huge depressions. So there is a highland area which is bright in color. There is a lowland area which is having dark color. Okay, so why it is dark? Because it is made up of dark colored rocks. And dark colored rocks, if we say, you can tell this is a picture of the rock brought by Apollo sample, and here it is dark color. You can see, and there are lots of vesicles you can see because the volatiles have escaped. When this material was cooling and rock was forming, then volatiles have escaped, due to which you see this type of vesicular basalt here. And this is having lots of calcium and aluminium. Calcium and aluminium, that is why the rocks in this area is bright in color. And here we have more Fe and Mg. And the far side of the moon, okay, which you don't see, thus if you just see, it is completely different from the near side of the moon. And we do not know exactly why this type of things have happened onto the moon. Just see towards the south of in this region, then you on the far side, the pointer is showing to that. You can see that this area is known as South Pole Attican Basin. Okay, this is the second largest impact basin in the solar system. And in the next slide, please, you can see this is about 2,500 kilometers in diameter. Okay, it is 2,500 kilometers in diameter, and depth also. Just imagine 11 kilometers, approximately 11 kilometers is the depth of this particular basin. So such huge structures were formed on the moon, huge structures, and several of them were formed on the moon. Okay, and just I will tell you, these structures were also forming on Earth long back when Earth was forming. Okay, next slide, please. So, if you want to know, see these impact structures, have a close view, then you can see in this particular slide. The first picture shows a impact crater of only micron size. When I say micron, it is 10 to the power -6, very small, 30 micron, and it has formed on a glass spherule. So that small impact crater. And as the size increases, you reach to a simple crater, bowl-shaped crater. Okay, this is called a simple crater. A 10-kilometer size one is shown here. And then as the size increases further and you go beyond a certain this diameter range, then you get some sort of a complex crater where you have a central peak which brings rocks from the subsurface deep. Okay, if somebody hits you, then there is a rebound, right? So that rebound brings deeper rocks from interior onto the surface of the moon, and then you can use your remote sensing techniques to study them and tell about interior. Then the walls have terraces. Okay, so these are morphological changes. Morphology of the features change, and as we go to even higher dimensions, say 300 kilometers, then you see a ring peak. And even when the diameter is even more than that, then you see about number of peaks are number of rings are coming, which is known multi-ring basins. So these are called basins. Those impact structures which are greater than 300 kilometer diameter are known as basins. Okay, and two of them are shown here. Next slide, please. Next slide, please.
Change it, sir.
Yeah. So here, so one of the feature was impact feature. The second feature is the basalt, which is an outcome of volcanism, Jwalamukhi. Okay? When there is a formation of magma inside the earth, okay, then magma comes up to the surface, flows in the form of lava, You go to Hawaii and you will see such type of features there. You go to even our Maharashtra, you go there, Deccan trap basalts are there. So similar basaltic plains are there. The differences are there, okay, because it's a different body, it's a completely different body. There will be differences, but broadly you can say similar type of rocks what we get in Deccan tracts is what is there are plains here, okay, and then you can see something written here, cobra head. So what is this cobra head? This cobra head is the source crater from which the lava has come out, and you can see this various sputterai. It is from this crater, source crater, lava has gone and gone and gone into this area, and then it disappeared here. Okay, so there is an impact crater at the Herodotus. This is an impact crater, and Cobra Head is the crater which is volcanic. So you have two types of features there. One is volcanic, other one is impact cratering related. Okay, then these are pyroclastic deposits. So volcanism can be very smooth, okay, smooth flow of the lava, but if there is lot of volatiles in the lava, in the magma, then you can have, and silica content is very high, then you can have lots of pyroclastic deposits also. Explosive type volcanism happens. Okay, so these are the pyroclastic deposits, and then we have some sort of dome structures which is having lot of silica. This type of things are having lesser silica. Here silica is more. If silica is more, you form domes. Okay. Otherwise, it will form plains. Please go to the next slide. Okay, fine. So here, considering all the studies which were done, major lunar crust terrains based on morphological and compositional information is shown here. Okay, I talked about morphology, I didn't talk about composition. If you want to find out composition of a unknown planetary body, then there are several techniques which you can apply. Okay, you need to do spectroscopy. So if you just measure the light which is reflected from the surface of the planetary body, okay, in different wavelength bands, then you can tell what is the composition of the surface. Okay, because this will be different for different targets. Similarly, there are other techniques like gamma spectroscopy, neutron spectroscopy, which can tell you about elements. Okay, X-ray spectroscopy, they tell you about which element is present in an area. So combining all the findings which were there from lunar prospector, then I told you Clementine mission, samples. So this was the outcome where it was shown that the Procelarum terrain, this is the terrain where we have lot of heat producing elements. Okay, so moon is getting more and more interesting. Earlier, what was shown? A simply black and white, okay, moon. But now you see the colors have come. Colors means it is compositionally different. Different areas of moon are compositionally different. Okay, so if you see this is near side, this is far side of the moon, and where heat producing elements are here. And I told you about the South Political Basin on the far side. You can see this is also compositionally different. Fine. Can you please go to the next slide? Okay. So I have made a lot of things here, but things are not seen here. So can we go to this? Okay, yeah. Now it has appeared. So basically, here through pictures, I'm trying to show you how moon formed and how it has evolved through time. Or in very simple words, when the moon formed, it was not like what we see today in the night sky. Okay, that is the very simple understanding about moon. So you can see here a Mars-sized object called Theia hit the proto-Earth when Earth was also evolving, and the debris it created was thrown, and this debris actually, coalesced to form the moon. And after the formation of our moon, what happened? A, a whole part, there was a formation of the magma ocean due to heat producing elements. And when these particles now, when these grains they coalesce, they impact with each other, then they accrete, and when they accrete, they produces accretionary heat. So that is also heat. So impact is not always destructive. Impact is many times constructive also. And due to this only planet form. So they are constructive in nature. So what happened due to this heat which they stored, a part or the complete moon got molten. And from in this molten moon we had slowly crystallization of crystals started. And then you can see here the calcium aluminum, the minerals which were having more calcium aluminum were lighter. They floated on the top, shown on the left hand side with white color things, okay, white color cubes. The white color cubes floated to the top, forming the anorthosite crust, and the uh, those minerals which were formed, having more calcium, magnesium, and iron, like olivine, pyroxene, they have sunk to the bottom. Okay. So you got a bright, very bright moon in the beginning, and crust of the moon had formed. But then after that, what happened? Volcanism started over it. Interior of the moon there was melting, and then volcanism started on the moon. And after that, what happened? Lot of impacts happened. Okay, again lot of impacts happened. Big impacts happened around 3.9 gigaannum on the moon, such as this South Pole eclipse which I told. Then you can see many more have come, and then volcanism also continued. And today it was understood that volcanism is almost dead. It was understood. I repeatedly say it was understood, because this is the past which knowledge which I am talking about. So volcanism, only little bit of impact event is happening today. Okay, please next slide, please. So this movie will give you, tell you what I just told you. It will showcase that. Okay, enjoy this movie, then I will just proceed further. Are you getting the noise, voice from the movie? Voice is not coming.
No, sir.
Voice is not coming. So what do we do? Actually, if you share it from the Google slide itself, direct through that, you just open that Chrome tab and share it. Share that tab. Then it will come. No need to download it.
Sir, here my network is very bad, so that it's not able to play. 1 minute, I
Okay.
am trying to connect you. 2 minutes.
Let me see if I can get it played. From here, if you can hear this voice. Huh? Just a minute.
Is it
Here,
visible, sir?
no, no, it was visible. So if you can make it visible, I can put it my mic here, and I hope it will reach you. I will play that from here. Huh? You please play from that side.
No, sir. I am not an a. It's
Huh?
a it's a off here, sir.
A voice
But
will be
try
coming.
try from your side, sir. I am unable to play. My Zoom is getting off.
But what we can do, we can I can again try to share the screen from my side.
Okay. You have
Okay.
options, sir. One
Let me
minute.
say, host, it writes host has disabled attendees
Now
screen
now you
sharing.
can try, sir. You can.
Ah, now it has come. Very nice. So, do you can you see
Yes,
my
sir.
screen
Yes,
now?
sir. Yes, sir.
Oh my
Yes.
God.
So that you can play your slides, sir.
Yes, yes. Yeah. Now it starts. Fine. Lunar crust has formed. South Pole it confirms now. To all the kids, just imagine the scenario on Earth. This type of things has happened on Earth as well. So please enjoy this scenario. Today, only very few craters you can find on Earth. Very few. Most of them are lost because of active planetary bodies. So this is the today's move, right? Now let me proceed further. Okay. Okay. Fine. So next slide. Well, go to the slide. Okay. So now I continue. So I gave you a feeling about how moon has formed and how it has evolved through time. That was the old story. Okay. But several studies, including one of the study which we also carried out, which is now shown on your screen. This particular study, they were telling his story is not that simple, that you just have a global magma ocean and then layers of rocks of uniform composition have formed. Moon is not having that type of uniformity. It is some sort of a heterogeneity is there in the depth. So in this study, for example, central peaks, I told you, if you study the central peaks of moon, you can tell about the depth, composition of the depth. So I also did the same. I studied the composition of this central peak and found that it is very at depth things are not homogeneous. There is a lot of heterogeneity in the depth. So using this titanium concentration, if you can find out if you can have you can target some of those plutons. We call in geology plutons. So what are plutons? Plutons are magma bodies which are just which could not come up to the surface. They somehow they just installed inside the crust of the surface, the crust inside the crust. If they come to the surface, they will produce a volcanic feature. If they could not come to the surface, they will produce a this pluton. It's called pluton. Of different type of shapes are there. You can see field. Okay, so this is the this was the first paper from lunar lunar geology from remote sensing from our country. One of the first papers, if I have to be very precise, two papers from our PRL came in the same issue of advances in space research. And one of my colleagues is in IIT Kanpur. So that was his paper, and this one the other paper. So these two papers were the first two papers in this field of research. Okay. And then coming to okay, so I told you that this there were several questions were coming up. So what were those questions from earlier, mostly remote sensing missions, Clementi and Lunar Prospector? They were posing a lot of questions. And what were their questions? The question was, what is the structure and composition of the lunar crust? Mental means surface, subsurface, and very deep. I'm talking about very deep. So is it adequately represented? So samples have been brought from moon, from few locations, but are they sufficient, or we require more samples? What is the diversity? What is the level of diversity? Then why a small body like the moon should have intense and long-lasting volcanism? A small body like moon should have died, should have cooled very soon and died. Okay, but we are seeing lot of volcanic activity, intense and long-lasting. It started long back, 3.9 gigaannum, even before than that. Okay, and we are talking up to 1.2 gigaannum. So why should we? And then what is the current geological state of the moon? Is it geologically dead? That was also a very strong, strong opinion built by the scientists who worked from Apollo samples and other things, that moon could not be geologically, moon should be a geologically dead body, and there cannot be water there. It is bone dry. Samples were not giving any indications of presence of water in the moon. So with these objectives, we thought, let us there should be a we should also look at the moon from our own perspective, and this led to a new era of lunar exploration, wherein we have our Chandrayaan 1, Chandrayaan 2, two missions we have listed, and you can see right from Smart 1 mission of ESA in 2003, the JAXA, the Chinese Chang'e series, then LRO mission of NASA, which is still there, doing excellent job. I can tell you, excellent job. Then again, Chang'e mission, Grail mission, all this is out of NASA. So many missions. A new era of lunar exploration started just to address these questions. Because if we address these questions, we understand the moon better, and then use it for our betterment, for our own betterment. Okay, so we will quickly see some of the findings from this, and for I will just tell you in very simple words. Chandrayaan, Chandrayaan was having a moon mineral mapper of NASA. Okay, I told you the light reflected from surface. If you just measure them in different wavelength bands, then you can tell about the composition. So there was an instrument on board this Chandrayaan 1, which is known as Moon Mineral Mapper. There were few more instruments of similar type on Chandrayaan 1, but Moon Mineral Mapper has given maximum science, and you can see they could find new rock types on the moon. Okay, which was not known earlier. So, so you can see these pink spectra. They are actually telling you in this particular area they got new rock types. Then, if you go to the another area, earlier understanding was that these huge impacts cannot penetrate so deep that they can bring out the rocks from the mantle of the moon. However, the remote sensing observations from especially from Kagua, they and then models also. People have modeled also now, and they you can see all the stars now. They are the potential rocks from the depth of around 50 kilometers or more than that. So mantle rocks was also probably exposed onto the surface of the moon. Okay. So these were again new rock types. When we say new rock types, these were not sampled during Apollo time. After that, new impact basins were found on moon. I told you what is basin. Basin is something which is greater than 300 kilometers in diameter. So several of them were not known because they are not seen. They are not seen. They got lost. They are so ancient that they are not lost. Either they are, their evidence is lost because somebody else has put lot of ejecta over it, or in due course of time it has degraded due to a process known as space weathering. Okay, wherein micrometeorites continuously bombard the surface and they create lot of soil onto the moon surface. Okay, and solar wind also both do this job. So basically, number of new impact basins were found. You can see those dashed lines, which are shown by dashed lines. And then I told you the moon was bone dry, but then several attempts, including Chandrayaan 1, then even sample science, and because techniques evolved, people can extract the OH H2O from the lunar glass sample. So they also found the water was there on the moon. And then from Chandrayaan, they could see that everywhere there was a thin and tube instrument. It found around 2.8 micron. There was a characteristic absorption feature. So moon has surface water everywhere. It gave a confirmed, confirmed. It confirmed this. Confirmed this earlier using this lunar prospector data. There, you had a neutron spectrometer, which told that there could be hydrogen on the polar areas of the moon, but it could not tell whether hydrogen could be in the form of water. This was confirmed from the InTube Chandrayaan 1 mission. So now this north pole of the moon is shown, south pole of the moon is shown, and these are the craters which are permanently shadowed craters. Why it is permanently shadowed crater? Because the tilt of the moon axis is very less. Due to this, those areas which are deep areas on the pole, they never see the light of the day. For, for several billion years, it is under this darkness, and temperature is very cold, around 70 K, 77 Kelvin. So this type of thing. So if a water molecule from any source somehow happens to get inside this area, it will remain there. Okay, it will remain there. It will mix with the regolith and will be there. There are processes by which it will be lost a bit, but okay, fine. Most of them will be retaining there. So this is North Pole, this is South Pole, and these are very important resources on Moon. And to get these resources, now there are so many plans uh, like ISRO JAXA mission, Artemis mission. They all want to go into this South Polar region and uh, see and study this type of deposits in detail to know about them. So it can be inferred that the moon is not a moon drive. So our understanding is now quickly changing. Now coming to the third one, that moon is geologically dead, a small body. So we found a very striking flows inside on the moon. You can see this type of features. If you go to Hawaii, you will see this type of features. And this is actually associated with the impact crater here, and this whole thing lies in a very big crater. So the big crater is known as Lunar crater. This is a small crater on the edge of this, and then we have this particular area where we have in the central part we have these basalts. So this basalt, yes. So these are the fresh flows on the moon, very fresh. But it is a very difficult problem in this subject, that whether these are impact melts of this particular crater or they are later formed volcanic flows. So you can see older flows here, and then these are very fresh, which and these are old. If I say old, because you can see lot of craters on the surface, whereas here we don't see any crater on the surface, on the top area. So this was a very new discovery, and you can see here they are flowing inside a fault, which is very nicely exposed in the central peak of this lower crater. Okay, two faults. This is a graben structure in geology. We say graben. One this fault, then this is another plane, and then this is the wedge failure activity. Okay, so this was a finding from our study, and then you can see this Lowell crater is shown a 3D view. You can enjoy the 3D view of the Lowell crater. It lies at the edge of this huge oriental oriental basin, which lies at the near side far side, western near side far side boundary. Okay, and in this particular study, multiple data sets were used. For example, Kagua TC data, Kagua mission, the Japanese mission, then LRO mission, and Chandrayaan 1 mission. All the data were used to, produce multiple evidences, and I can tell you, almost every evidence tells that they are basalts. They are not the impact melt of the small crater just associated with this. So on the basis of that, you can just see those flows in a very zoomed versions here. So this type of flows, okay, viscosity of these flows are very high, and you can see here pits which are surrounded by vesicles. Then there are pits on the surface which shows exclusion of melt. So these are sources, small, 100-meter, 50-meter. 100-meter is not very small. If you go to football field, that is the dimension. Okay, so cricket with 600-meter six, you do not those things. So this type of big depressions are there. Okay, and you can see vesicles are formed because of the loss of volatiles. That is why where these vesicles are formed. Okay. Then there are pressure ridges. So all these tells that they are volcanic. But this one from Chandrayaan actually provided much required thing because the composition of impact melt and melts is same as the target rock, whereas here the composition has changed. The composition of the top surface is this, whereas the target rock is this. Therefore, what we inferred was the generalized fresh flow formation inside the lava crater is a cumulative outcome of localized. I'm sorry, these are complicated statements for you, but Moon had volcanism around 2 to 10 million years ago. That is the outcome of the study. Fine, we provided many evidences because it, for long people have a very strong, opinion about this thing. Moon is geologically dead, and today, if I just a person who starts career and after some 10 years or 7 years he says the moon is alive, nobody will believe you. So it lot of resistance is natural for this, but I can tell you that now most of the papers which are published, they talk about some sort of geological activity on the moon, may it be volcanic, tectonic. Some of the glimpses will show quickly. Okay, now the question here was why the melt is produced in this, very young age. So for long time, theory exists that the Procelarum creates terrain. This terrain I showed you earlier also, where heat producing radioactive elements are there. They produce this, they are continuously producing the magma in the interior. But from our remote sensing observations, we can see here the recent volcanism is not only found in this area, uh, it is also found in several areas which are far away from this particular region. Okay, and one such area region in this area where we have worked, I will show you. My student Kanu worked over this, and you can see here. This this is the Grimaldi Basin on the moon, and just below you see here you don't see any impact structure. It's so old, it is gone. You don't see them. Only Grail could see it because Grail could see the subsurface. Huh? It is through its gravitational measurements. So here she found volcanism which is as old as 700 million years. So what was the earlier number? It was 1.2 giga annum. Okay. Now from billion years we are coming to million years. So it is coming to 700 million years. In the previous one, what I talked was 2 to 10 million years. Just 2 to 10 million years. So just see the continuity. Okay. And this particular basin also experienced very recent tectonism around 50 million years. So moon is geologically active. And then this area which was not seen, that area, geology of that area was studied by Tanu, and she could find basin, lot of uh, lot of late phase volcanism in this area. This basin actually is a very small basin. It's a very small basin. Okay, but it uniquely it exhibits very prolonged volcanism on the moon, which is 3.9 giga to 1.5 giga. So why it is happening? So what is the role? See, if now I just explain you very simple thing. If suppose I don't know that there is a basin here, I will say this small crater can produce a volcanism here, right? But now you see, actually there is a basin which was not visible, and all these basalts are is related to this particular basin. So impact basin appears a prerequisite for volcanism on the moon. They have a very uh, intimate type of relationship. Even on Earth, there is a relation, but it's very difficult to work out on Earth since this type of things are almost evidences are lost because of its active nature. Now, we wrote a new volcanic history of the moon. The topical phase, we introduced this phase which is known as topical phase, that is less than 100 million years. Okay, and then there was a late phase volcanism which was earlier up to 1.2 giga-annum, but we have brought it down to 700 million years. And then main phase, pre-cataclysmic phase remains as it is. Okay. Now, these are my concluding remarks from this thing. The international space missions to the moon during past decade and a half have considerably changed our understanding of the moon. Geologically, it is much more diverse, and contrary to the expectations, the moon's interior is heterogeneous, and it shows evidence of recent volcanism, tectonism, and it is enriched in volatiles. These findings are not in agreement with our current understanding of origin and evolution of the moon. So what do we do now? Okay, remote sensing can only, by nature, is a reconnaissance survey. You can do reconnaissance, but you need samples in your lab if you really want to rewrite they are giving the evidences indications, but you need to develop the theories. You have to bring them. So new sample returns and in situ missions, they are required to address these issues and put forward another giant leap in the field of lunar and planetary exploration. Okay, and you can see recently Chang'e 5 has brought samples from this particular area of the near side of the moon, and this is the youngest dated moon rock, moon basalt. Okay, this is the youngest dated moon rock, and it formed around 2 gigaannum, 2 billion years, 2 into 10 to power 9. In geology, that is young. 2 is young. Okay? And the mental source region for this, and this is also not having a, if you remember my earlier slide, creep is the same area, but the sample tells that creep, they are of not having creep origin. So creep is not required to produce this this melt in this interior. Creep is not required. What we were telling for long from the remote sensing, now this sample is also telling the same thing. So what would be the alternate scenario for the origin of younger salts? That is the question. And most probably it is the, we have to, unless we understand the relation between impact cratering and volcanism, we will not be able to address this problem, and that is what we are doing. So as far as samples, new samples were concerned, we have already selected a few broad potential target sites on the moon for in situ and sample return in future, and uh, we need more. It's not only one mission. We need several missions to, then only this will be settled. And international approach is required if we want to understand moon better. And this is that Moscow-Bielski basin. In this Compton Belkovich region, I told you silicic volcanism. This is a little different type of volcanism which happens on moon. And our team from Space Application Center has extensively worked in this region. Then here in this Oriental basin, we have the recent volcanism I already showed you. Okay, and this oldest basin is recent. This was here on the Chang'e 4 landed using a rover. It is trying to, uh, it has landed and it is trying to understand what type of in situ study rocks, and they have found mantle rock, and in an area which was proposed in our first study. In our first study, which I showed you in a previous slide, the first publication from our country, we, for the first time, we proposed that in that particular area there is a possibility of a mantle rock or mantle derived rock. They landed there, they got it. So the journey has just begun.
Nine, eight, seven, six, 5, 4, 3, 2, 1.
hope all of you
Liftoff
identify.
normal. P1
Here
tracking.
we have a majestic liftoff of LVM-3 M4 rocket carrying India's prestigious Chandrayaan-3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण उत्थापन LVM-3 M4 रॉकेट का। यह भीमकाय रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है, जिसे हम यहाँ महसूस कर सकते
हैं। And where it is going?
Eight, seven.
Yes. So it is going to this particular point. Okay. So this is a highland. As I already explained, this is the highland area where this Chandrayaan 3 is heading towards. And if you see, this is the south pole of the moon. Okay, there is a crater called Shackleton crater, by which we always identify the south pole of the moon. And here is this area is where we are going, and it's a very challenging mission. Okay, because as we go towards higher latitudes, none of the countries have actually landed at this high latitude. None of the previous missions have landed at this high. This is very challenging because sun angles and all of, plays a very, very crucial role in imaging things. It's a very complicated mission, and I'm pretty sure that our team ISRO will make it a success this time. And what do we get out there? Here, I told you that 3.9 giga-nm, lot of impact happened, this happened, that happened. They created a kilometer thick ejecta on moon, which is known as mega regolith. So in this area, the mega regolith is that particular mega regolith is present in its very pure form, undisturbed form, and that is none of the earlier missions have sampled that type of area. So if we can get that, we can talk about again same thing, the level of heterogeneity of moon, and all those things we can talk about. Lateral heterogeneity means one surface to another on the surface, what type of heterogeneity exists. If we go to depth, what type of heterogeneity exists. So all these type of things we will try to address. It will be very difficult task, I can tell you, but we will definitely try to address some of these questions. And this is the view of this site where we are going to land, and this is the blown-up view from the best camera available in the world. That is the OHRC camera, which is just on board Chandrayaan 2, developed at our Space Application Center, Ahmedabad. Okay, this has a spatial resolution of 25 centimeters, and it can detect boulders up to some 1 meter boulders you can see on the moon surface. So you are going to a highland area. इन्हीं पहाड़ियों में आप जाएंगे. We will go there and we will do science, and this will lay, this will be an important step actually. For what? If you have time, I can just go to my next video, and it will be an important step for this. Thank you so much. I am done. So if there are any questions, I will be very happy to interact with students.
Thank you, sir. Any question? Quick question and answer. If any questions, please raise your hand or you can unmute yourself. I am giving the option. Very quick question and answer. Girish sir, anything to discuss?
Good evening, sir.
Okay. Nikhil Verma.
Yes, ma'am. Good evening.
Yes. Huh.
Yes, sir. Sir, does the plateau colonization occur on the moon? Like at the...
Sir, you are muted. Just unmute yourself.
Sir, got my point?
You are muted, sir. Unmute your mic.
Unmute. Yes.
Yes. Okay.
Yes, please tell me.
Nikhil.
Yes, sir.
Nikhil,
Sir, does the plateau colonization occur on the moon like Earth?
No. We don't have plate tectonics on moon. Okay. It is a single plate body. It's a very
Sir,
small
what?
body. It's single plate.
Okay. Sir, that means... Sir, pardon, I am not able to understand.
It is a single plate body. We do not have plates collision like what we have on Earth.
Okay. Okay, sir. Thank you. And one more question, sir.
Yes. Continue, please.
Yes, sir. Sir, how the process how our moon is formed, does that process is applicable to other moon?
See, it is not like that. Our moon formed in a very, very special scenario. Okay, as per our understanding. If you talk about Mars, the Deimos and Phobos, they are very small captured objects. Okay, so
Okay.
they will be lost very soon. They are not the permanent satellites of just like we have on our Earth. Okay, and if you go to the outer solar system, there most of these small satellites they are having number of them, right? So it is either this co-accretion or capture. So they you do by capture or co-accretion. But Moon has formed in a very special circumstance.
Yeah, sir. Thank you, sir. Sir, and one small, sir, what is mean of dead moon? What is meant of dead moon?
Dead moon. Dead moon means there is no internal activity. Okay, we cannot expect any volcanism on moon. Okay, we cannot expect any sort of formation of tectonic activity on moon. Okay,
Okay.
so for example, you would have heard about moonquakes. Moonquakes. Have you heard about moonquakes?
Yes, sir.
So if there are moonquakes, this means some activity is happening inside that. That is why it is the moonquakes are happening. Okay, forces can be external. This is the new thing which we at PRL are trying to introduce. Okay, the
Yes, sir.
tidal force of Earth can cause a moonquake. Okay,
Yeah.
but the activity happened on moon. So that is sort of a thing. Even impact happens on okay, and then due to that impact you have a quake. So
Yes.
that type of activity happens. So that was known earlier also, but the what the dead moon what we are talking about is that moon doesn't have any sort of a molten magma in the interior. whole moon has got become solid now. Okay, so there is no possibility of any sort of a volcanic eruption on moon from interior, because interior is solid and there is no way to produce the magma during recent time. So it is a dead body. That is the dead moon. Okay.
Yeah,
We say no, moon has molten material inside it
yes,
even
sir.
today, and they are coming out due to certain external reasons, external scenarios. Okay.
Uh, yeah, thank you, sir. Thank
Okay. Uh, Next question.
Hello, sir. My name is Draksh. I am from class 6B. Sir, I have a question that why what was the reason of that Chandrayaan 2 was failed?
Rudrash, see,
Yes, sir.
the major reason, you have asked me a very difficult question, possibly the most difficult question, because I don't know the answer. Okay, I
Okay,
can
sir.
tell you, in the first attempt, we reached that place very near. Okay, so
Yes, sir.
I told you now those things. You should pump yourself from that. You should read the story of Apollo 1. Rudrash, you should read the story of Apollo 1. Apollo is the most famous, mission from moon. So you should. I will not tell you, but you should read it and sometimes get back to me. So
Okay,
failures
sir.
are a part of that, and I can tell you I don't have that technical know-how why it failed, but I am very happy to see that in the first attempt itself, the system reached the place where it wanted to go. Even that is very difficult. People, I think the Change team wanted to land at some place and they have landed some very, very far from that place. Okay, in the first attempt. So these things are something, it's a part and parcel of things. But I'm sorry, I don't have the technical answer to it.
Okay, sir. Thank you, sir.
Mhm.
We are running out of time. Any questions? Okay. I think
Sir, I am Mallesh.
Malesh, any questions?
Yes, sir. I want to
Well,
know when we land on moon, is there any survey? Is there any vehicle which will go around the surface?
yes, we
Ah,
have a we have a lander this time and a rover there. Okay, so rover will be coming out after the landing operation is successful. Then there will be a rover. Rover will come out. I think still Pragyan is the name, and it will come out, and that is having two instruments. Okay, one is alpha particle X-ray spectrometer, and the second one is laser induced breakdown spectroscopy, LIBS. So APXS was built by PRL, LIFT from LIAS. So these two instruments are there on the rover, and the rover will go around and try to study the elemental composition of the area. So this is on the rover. Then we have several instruments on the lander.
ah,
One is chaste, okay, which is which is try to insert a probe into 10 centimeter of the moon, first 10 centimeter of the moon, and
hmm.
will try to find out the temperatures and thermal, will study the thermal conductivity, all geophysical parameters will try to study of the first 10 centimeter of the moon. Okay, this particular payload was built by BSSC and PRL in collaboration, and then we have a Rambha payload which will tell about the plasma environment of the area. So these are some of the instruments which have gone on our Chandrayaan 3 mission. And there
Thank
is a
you, sir.
shape payload. Okay, there is a shape payload which will be there in the orbit. Okay, there is a propulsion system which will be in the orbit for some time, and the shape payload will observe Earth to find out the key evidences which it will consider Earth as an exoplanet and study it. Okay, so that this will help us in finding out life on other exoplanets.
Okay.
Thank you, sir. Thank you.
Uh, shall we end here, sir?
Sure.
Okay. Thank you. Thank you, Dr. Neeraj Srivastav, sir, for accepting our invitation and sharing insight knowledge with all creative participants. Thank you, one and all, for joining with us. Thank you. We are ending here.
Ma'am, this was a great opportunity for me to interact with the
Yes.
kids, and I was very happy to do that. So
Yes.
thank